Section 6.5 is where we are going to do operations with radical expressions. So we're going to be adding, we're going to be multiplying, and simplifying some that have variables inside of there. So for example, we're going to be using multiplication to multiply some things. We're also going to be dividing. All right, so we've already talked about how we can simplify our different nth roots. So far, they have come out as nice whole numbers. You still want to check this on your calculator because some of these may turn out as to nice whole numbers, some may not, okay? So the first thing I'm going to do is I'm going to find the cube root of negative 27. So I'm going to go to math, I'm going to go down to number 4, and I'm going to type in negative 27, and I get negative 3. So right off the bat, I'm going to know that that first value is negative 3. This is the same as what we did before, where we are going to raise this to the 1/3. So I also could have done negative 27 raised to the 1/3 power and still got the same thing. So if I type in negative 27 raised to the 1/3, I would still get negative 3. I'm also going to distribute my exponent to this. So when I have a power to a power, that's going to multiply, and that's why I'm going to get a to the second. And then I'm going to do my 14 raised to the 1/3. Now here's where the issue becomes, because when I was doing 14 divided by 3, not a whole number, right? So when I divide 14 by 3, I get 4 as a whole number, okay? So that means 3 is going to go in there 4 times, and then I would be left with 2 after that. So if I change this into an improper fraction, this is what I would get. So here's what happens. When you have 14 b's, all right, we're going to break them into groups of 3. So I have one group here, I have 2 groups here, I've got 3 groups here, and then I got 4 groups there. Those groups, since they make a group, are going to go on the outside, so I get b to the 4th. That's that whole number that you're getting in your head. The ones that are left over, your remainder, is what's going to have to stay on the inside. So remember when we broke out with our factor tree, and anybody that made a group gets to come out? Well, that's what happened here. I had 4 groups that came out. And then on the inside, I have my remainder of what was left over. So I still had 2 b's that are left inside. Okay, let's take a look at another one. So the first one I see is 75. This is all going to get raised to the 1/2, right? So I'm going to type in 75 to the 1/2, or I'm going to do the square root of 75, and I get this long decimal. So that tells me that 75 cannot be done with the square root. So this is where I'm going to break down 75. So I'm going to divide 75 into 3 and 25. 25 is going to break into 5 and 5. I am doing square roots, so this is different than the first one. I need groups of 2 now, when before I was doing groups of 3. Okay, so I'm finding groups of 2, and that 5 is going to come out, and this 3 is going to stay inside. Then I'm going to see if I can do half of 12. Well, that's easy because half of 12 is going to give me 6. Then I'm going to try the last part where I do half of 7. I know 7 divided by 2 is not a whole number, but I do know when I divide 7 by 2, I get 3 groups and a half left over. In other words, if I wrote out 7 y's and I pair it out, I get a group of 2 here, group of 2 here, and a group of 2 here. So I'm going to get y to the 3rd to come out, and stay underneath my square root, I'm going to have that 1 left over from my remainder. Now I'm going to put them all together. So everybody who's on the outside is going to go on the outside. Everybody who is under the radical is going to stay underneath the radical. Pause the video and see if you can try the next two. So on the next one, I would find the cube root of -8, and when I type it in, I get -2. Then I am still doing a third, so when I did a third of 3, that's easy because that's going to turn into just 1 as a whole number. When I do a third of 7, I got 7/3, which as a mixed number becomes 2 and 1/3. If you're confused, write out that you've got 7 y's, and I'm making groups of 3 because I have an index of 3. So here's a group, here's a group. That is why you're getting 2 wholes, okay? Then my remainder of 1 is what's going up here. So when I'm writing my answer, I'm going to have y to the second for my 2 groups, and that other y is going to stay underneath the radical. So this would be my answer. Okay, so then on the last one, when I do the square root of 80, it doesn't work out. So I'm going to have to break down 80. So this is how I decided to break it down. My index over here is a 2. So I'm doing groups of 2 now. So I have a 2 here and a 2 there. So that means I would have 2 from this one and a 2 from this one and then a 5 left over. A to the 5th to the 1/2. When I divide those, it doesn't go evenly. It would go 2 in there evenly, and I'd be left with 1. Okay? So I would be having 5 A's if you want a visual. I'm making groups of 2. That's where this 2 comes from, remainder of 1. So I would have A to the second for my 2 groups. Remainder has to stay underneath that A. B to the 10th, I can do that and get B to the 5th. So that's why we have 2 times 2, which is 4. My A squared and my B to the 5th all going outside. Everybody that was under the radical gets to stay inside. Okay, now let's look at quotients. So for quotients, you're going to do a similar pattern. You're going to make sure that you're finding the cube root of everybody to get started. Okay, so I'm doing cube root of 24, cube root of a to the 6th, cube root of 125. Please just remember who is on top and who is on bottom. Okay, so these two were on top. When I type in the cube root of 24, it's a decimal. So that tells me that I'm going to try and break it down and see if I make any groups of 3. So I broke it down to 2 and 12. I kept breaking it all the way down, and I found I had a group of 2's in there. So that means that group of 2 would come out. And then I would be left with that 3 underneath my cube root. Then over here, I'm doing the cube root of a to the 6. This is going to be rewritten as a third of 6. So that's why I did a to the 2nd. Last, I was doing cube root of 125. When you type it in your calculator, you get a nice whole number, which is just 5. So then I just need to remember who was on top and who was on bottom. So I had these guys on top. So 2a squared with the cube root of 3 is on top, and then your 5 is on bottom. Let's look at another one. So over here, we have 4th root of all of this stuff. So you're going to break it apart, remembering who is on top and who is on bottom. Okay? When I type in the 4th root of 80, not a whole number. So I'm going to break it all the way down. This time I'm finding groups of 4 because my index is a 4. So I found a group of 4 of 2's. So that means I have a 2 on the outside and anybody who didn't group left inside. Over here, I have 14 Ys. So you can divide 14 by your 4. So I would be getting 3 groups of Ys and 2 as a remainder left over. So I would have y to the third for my 3 groups of y and my 2 y's left over in the radical. On the bottom, 4th root of 256. When I type in the 4th root of 256, I got a nice whole number, 4. Then over here, when I did the 4th root of z to the 4th, I can divide that evenly, and that just gives me 1. Again, remember who is on top, who is on bottom. So I put all these things on top. So 2y to the third, 4th root of 5y to the second on the top. On bottom, we still have 4 and z. Pause the video and try the last question. So on this last question, break it apart. So we got everybody that you need to do. So I did all of my ones on top, all my ones on bottom. So cube root of 90 is not a whole number. I'm looking for groups of 3, and when I broke it out, I didn't find anybody that was a group of 3. Then I had 8 A's, so that means I could find 2 groups of 3, or if you're dividing, 2 goes into 3 2 times, and then you have a remainder of 2 left over. Over here, you had cube root of b to the third. That's just a nice 1 group. On the bottom, you had b to the 9th. If you find that 1/3 of 9, gives you a nice b to the third. Okay, so then all these went on top. So things that were outside were a squared and b to the first. And then you have your cube root of 90 a squared. On bottom, we have that b to the third. Now this one had an extra step to it because you had like terms on top and bottom. See how you have these b's? So remember when you're dividing, what do you do with those exponents? You subtract. So if I subtract 1 from here, I'm going to be left with those 2 b's down there on the bottom. Okay? All right, so that takes care of day 1. Now you're ready for day 2. So now I'm going to be adding, subtracting, and multiplying. Okay? Okay, so for 6-5 day 2, we're going to add, subtract, and look at multiplying. So on this first one here, in order for you to add and subtract, same rules apply where they have to be like terms. So in order for them to be alike, their radicands have to be the same, which means this piece under the radical has to match. So if I have 2 square roots of 3 plus 5 square roots of 3, these match, so I can add them together. I just add the outside number, and then this stays the same. Same would be if I had 2x squared plus 5x squared. This would be 7x squared. So add the outside number, and then the inside stays the same. Okay, so as you look at this first example, you're going to notice that none of these are matching. So what you need to do is you need to break them down and see if they'll simplify to see if they'll match. So this 45x, I went ahead and I broke down into 3 or 5 and 9. And then I am looking for groups of 2 because I have a square root. So I had this 6 from before, this group of 3s that's coming out, and then my 5 is staying underneath along with that x that's already under there. Okay, then I'm going to break down the 12 as well. So I broke it into 3 and 4, found my group of 2s. The group comes out, and this 3 is going to stay underneath there. And then last, I have my 20. So I broke it down to 4 and 5, and then broke it into a group of 2s. So I have my -3 from here from before, my group of 2's coming here, and then my 5 is coming down here, and my x has not changed. So then I'm going to simplify. So I'm going to multiply this, and I get 18 square root of 5x. This doesn't change, plus 2 square root of 3. And then I have -6 square root of 5x. Notice after we simplified, these two are alike because they have the same radicand. So I can combine those outside numbers. So that's where I'm getting the 12 square root of 5x, and then plus 2 square roots of 3. All right, pause the video and see if you can do the next question. So on the next question, you can actually just ignore that negative and break it down like normal, but the cube root of -8 is -2. So this would be something that if you typed into your calculator, it would give you -2, and then I just brought my negative down. On the next one, I broke down 192. I'm looking for groups of 3 again. So I have a group of 2's here and a group of 2's here. So I brought down my 3. This 2 is going here. This 2 is going here. And then I was left with a 3 with this x left over. Then on the next part, I'm simplifying 24. So I broke it all the way down. I got a group of 2's. So I dropped down my 4. Put in my 2 on the outside. Anybody left over is staying inside. Now I'm just simplifying. So I had +2. I'm going to multiply all these, and I got the 12 cube root of 3x. Then I have my -8 and my cube root of 3x. Notice once I did all my simplifying, these two guys are matching. Then I can combine them. So I still have my 2, and then 12 minus 8 is 4 of those cube roots. All right, let's take a look at multiplication. So what you want to do for multiplication is multiply and then simplify. Okay, so multiplying is similar where you're going to multiply the things outside and then multiply the things on the inside. So 4 times 3 is going to give me 12 on the outside. Then I'm going to multiply on the inside, so I've got -160. Remember, when you are multiplying, you don't multiply the exponents, you add them. So that's why it's x to the 6th and y to the 10th. So apply those exponent rules. Then I decided to break down -160. So I'm going to have this negative from that 5. I'm just going to throw it out here so I don't forget about it. So I know it's going to be -12. I'm looking for groups of 5 now. So I found a group of 5, or a group of 2's here. So that's going there. I didn't have anybody to group with the 5. Then I'm going to have to split these 6 y's into groups of 5. So that's why you have one group that came out and one left inside. Remember, if you're dividing, you would have had one that went in with a remainder of 1. Then for this one, I was doing groups of 5 of 10, and they all broke out evenly, so that's why I got y to the 2nd. Then I just multiplied, so I would get -24 xy squared, and then still have the 5th root of 5x. Pause the video and see if you can do the check question. Okay, so start by multiplying. So I would have -6 on the outside, and then the 4th root of 625 x to the 5th, y to the 3rd. So I'm going to break down 625. That's where I found my group of 5's. So I'm finding 4 in my group. That was just a nice whole number. So I get to throw that on the outside. Then I'm breaking my x's into groups of 4. So I found my group of 4. And I had 1 left over. So I have one group of x's that came out, and then I have my 1x that's staying inside. Then for your y's, you don't make any groups. So since it's less than my 4, that's how I know it's just going to stay underneath. So then I just multiplied my numbers together. So I have negative 30, x, and then the fourth root of xy to the third. All right, that concludes day 2. So now you are ready for day 3. Day 3 is where you are going to multiply some binomial expressions that have radicals inside of them. So for example, if you have something like this, you're going to still do your box to multiply them out. Okay? When you multiply, the degree of the radical will not change. Okay? So the index isn't going to change when you are doing those. So here we go. So I have a sports pennant that has the following dimensions. Find the area in square inches of the pennant. So the first thing is I see I have a triangle shape. If I'm wanting to find the area of a triangle, I'm doing a half times base times height. So this is my formula that I'm going to use. I see this is going to be my base, and I see this is going to be my height. So I'm just writing it down what it would actually be. Now is where I'm actually going to do my multiplication. I like to distribute this through, okay? I'm going to stop here. I'm not going to multiply it times both of them. So I went ahead and multiplied half times 7 and a half times 6. So I'm just multiplying those outside numbers. In order to multiply these binomials, you get to do your boxes, right? So I broke out the top one from the first set, and I broke out the second one from the side one. Then I multiplied. Outside numbers multiply, inside numbers multiply. Outside numbers multiply, inside numbers, and so on and so forth. Outside, inside, outside, inside. Okay, so making sure you're multiplying out with out, in with in. Then I just rewrote it over here so that you could see what all of my terms were. I'm going to see if any of those will simplify. Square root of 64 is a nice whole number. That's just going to be 8. So I know I'm doing 10.5 times 8. Over here, square root of 24 is not a whole number, so I broke it all the way down, dropped down my 9. I'm finding groups of 2 because it's a square root, and then I'm left with 3 and 2 underneath there. Over here, 8's not a perfect square, so I broke it down, found my group of 2, dropped my 14, put my 2 here, and the leftovers go inside. 3 doesn't break down, so it's going to stay as is. So then I just simplified a little more. So these two multiplied to 84. This multiplied to 18 square root of 6. This is 28 square root of 2. And then I have 12 square root of 3. None of those can be combined because none of those radicands are the same. Whew, that was a long one. So pause the video and try the next question. All right, so in the next question, you're multiplying to find the area of a rectangle. So this time I'm doing base times height. So if I'm doing base times height, I see my base, I see my height, so I can go ahead and set up my two expressions. Then I'm just going to multiply using my boxes. So that's what you see down below here. I wrote it all out so you could see what all four terms were, and then I started simplifying. Square root of 49 is 7, so I can multiply 7 and 120. 35 does not pair out, so that's why it stayed as this. 7 doesn't pair out, and 5 doesn't pair out. So this one was a little bit easier than what that last one was. Okay, so that concludes day 3 of section 6.5. Now you are on day 4. So day 4 is where we get to rationalize the denominator. So first off, what does rationalizing the denominator mean? Rationalizing the denominator means that you cannot have a square root in the denominator. So it's not considered simplifying if you had. So your first step is always just simplify it, okay? So simplify top, simplify bottom. So I broke out 20 and I got 2 square roots of 5. Then what you're going to do is multiply the top and the bottom by that square root of 5. Okay, so whatever this square root is, that's what you're going to multiply top and bottom by. Because when you multiply across, you get 6 squared root of 5. This part right here, this will always give you a whole number. I wrote it all the way out, but I do this part in my head, okay? This would be square root of 25. Square root of 25 I know is just 5 because here is your group of 2, so it's going to come outside of that square root. So I would have 2 times 5. So I typically skip this step and just write this part. Then I would multiply. I would get 6 square root of 5 over 10. And then I can simplify my like terms. So those with square roots, those without. So 6/10 can reduce to 3/5, and your square root of 5 is still on top. All right, so pause the video, see if you can do letter B. So simplify square root of 28, so you should have got 2 square roots of 7. Multiply the top and bottom by square root of 7. When you multiply, you should have gotten 4 square root of 7 on top. On the bottom, this will be your group, so that's going to come out of the square root. So 7 and 7 is 49. Square root of 49 is just 7. Multiply the bottom. These are my like terms because they don't have square roots, so that's going to simplify to 2/7 with your square root of 7 still on top. All right, what's it look like when you have variables in there then? The steps don't change, okay? So I'm still going to simplify as much as I can, and then I'm going to multiply top and bottom by square roots. So top stayed the same. I am simplifying the bottom part. So square root of 25 was just 5. I'm finding groups of 2 of 11 W's. So 1, 2, 3, 4, 5. So I had 5 groups with 1 left over. I am multiplying top and bottom by that same square root like we did before. Then I'm going to simplify. So I have 3W squared, square root of W. 5W to the 5th. These two dies, same as before, it's going to become W squared. The square root and the square undo each other. So that's why I just wrote it as W. So if you, again, want to skip this step, this just becomes W. Okay, then I keep simplifying. Top can't do anything, but I see on the bottom I've got some W, so I'm going to put those together. So I get W to the 6th. Then I again see like terms. This can't reduce, but this can. So I'm subtracting 2 from the 6 W's on the bottom. That's why I got W to the 4th on the bottom, and these have disappeared on top. So I have 3 square root of W over 5 W to the 4th. All right, pause the video and try the next question. So simplify. So you should have gotten 2y to the 3rd and then the square root of 3 on the bottom after you simplified this part right here. You're going to multiply top and bottom by that same square root. Multiply all the way across. So 5y to the 3rd square root of 3, 2y to the 3rd square root of 9. Remember, this becomes a nice whole number, so that's just going to turn to a 3. Simplify again. So I'm going to multiply these two guys, so I get 6y to the 3rd. Then I'm going to check for like terms. 5, 6 doesn't reduce. I see y's on top and bottom, so those are going to subtract, leaving me with no y's, because 3 minus 3 is 0. So I have 5, 6 still, and my square root of 3 on top. All right, one more where you are rationalizing the denominator. What happens when you have this expression with that square root of 7? So the previous ones, it was all multiplication down here. But now since they put that minus sign in there, that stops us from just multiplying by square root of 7. So now you're multiplying by something called the conjugate. So that means you're going to take this whole expression and change that sign. Okay, so this was minus and now it's going to become plus. You still have to times the top and the bottom by the same thing. So I'm going to distribute my negative 5 on top. So I get negative 50 and then minus 5 square root of 7. On the bottom, you're going to need to do your boxes, okay? So I wrote out my boxes. I multiplied everything out. I rewrote them over here so you could see what terms I got. These two should always be canceling out. If they didn't cancel out, you did something wrong. So those canceled out, so I get 0. This should be a nice whole number. It should be this one right here, right? So there's my pair. So 289 square root of that is just 17. So then I can subtract those two, and I get 83. So I wrote it like this because this was my numerator. So I'm going to rewrite it with that. And this ended up simplifying for my denominator. So the only issue comes with organize your paper so that you remember what was on top and what was on bottom, because kids start to struggle knowing where to put it in their final answer. Okay? All right. Pause the video and try letter B. So on letter B, you should be multiplying by the conjugate, which would be 3 minus square root of 3. Distribute the top, so you should be getting negative 12 and positive 4 square root of 3. On bottom, you're going to do all of your boxes. So once you did that, these two are going to cancel out. This one I went ahead and just changed to negative 13. So that is why I got negative 4 on the bottom. And on the top, I still had this guy. Now, this actually can take one step further because you can split this apart. Divide this by negative 4 and this by negative 4. So negative 12 divided by negative 4 is positive 3. Positive 4 divided by negative 4 is negative 1. So that's why I took it one step further. There is a ton of material in this section, so just make sure that if you have any questions, you are reaching out.